Intelligent Transportation Systems Podcast. Hello, we are back again with the ITSPodcast episode 5 for September 2013. I'm Javier Sanchez Medina from the Intelligent Transportation Systems Society. We're here again bringing you top stories on intelligent transportation systems science and engineering. For this new episode, we have a really cool interview with Professor Frank Truss from the University of Utah about human factors and its relationship with ITS. Frank Truss is president of the American Psychological Association's Engineering Psychology Division. You can't miss it, it's really interesting. We also have some news about recent tests with motorcycles and bicycles using connected vehicles technology at the University of Michigan, and a transportation in history mini section on the step from velocipedes to the first motorcycles at the end of the 19th century. That's the menu for this episode. You ready to start? Here we go!
This is the news mini section for episode 5, September 2013. Motorcycles join nearly 3,000 vehicles equipped with wireless connected vehicle devices operating on public streets in Ann Arbor, Michigan. The Connected Vehicle Safety Pilot Model deployment is the largest real-world test of connected vehicle technology ever. The U.S. thought, in partnership with the University of Michigan Transportation Research Institute, has launched a motorcycle study to determine how vehicles and motorcycles interact using vehicle-to-vehicle (V2V) communications. 6 motorcycles and a bicycle have been added into the deployment area this summer. The motorcycles and bicycle have been equipped with vehicle awareness devices that transmit basic safety information, such as location and positioning. According to last June MIT Technology Review article titled "The Internet of Cars is Approaching a Crossroads," the expected cost of the needed wireless infrastructures could stop its development, at least for now. At the end of the year, the Department of Transportation will decide whether to mandate that future cars include some sort of vehicle-to-vehicle communication technology or leave it to the market. Sven Baker, Executive Director of Stanford University's Center for Automotive Research, said, "The biggest issue is where future funding would come from. Car makers would pay for onboard equipment and pass that cost on to car buyers, but the government would need to pay for technology to be added to roadside equipment and for the means of regulating and managing the overall system." Finally, one first call for the next IEEE ITSC 2013 conference in The Hague. Perhaps you're interested in extending your registration by picking any workshop or tutorial at the Workshops and Tutorials Day. They will include such challenging topics as simulation-based dynamic traffic assignment, green railway, wireless charging electric vehicles, swarm intelligence in air transportation, or source-coded traffic management for extreme congestion. Please visit this podcast post for further information and links.
Transportation in history. Motorbikes. When do you think motorbikes were invented? Did you know that they were steam motorbikes before the internal combustion ones? The bicycle is an invention of the 19th century. Many different prototypes were developed from 1810 to 1890, from the hobby horse to the velocipede or the safety bicycle. The Latin term velocipede means fast foot and is by definition a human-powered land vehicle with one or more wheels. The most common type of velocipede today is the bicycle, but it includes the monowheel, the unicycle, the bicycle, the dicycle, the tricycle and the quadricycle, developed between 1817 and 1880. But it looks like engineers, as the end of the 19th century was arriving, decided to substitute the human force by other kind of power units, steam motors, and afterwards internal combustion motors. There are basically three prototypes widely accepted as the precursors of modern motorbikes. The Michaud-Perrault steam velocipede was a steam-powered velocipede made in France sometime from 1867 to 1871, when a small Louis-Guillaume Perrault commercial steam engine was attached to a Pierre Michaud manufactured iron frame pedal bicycle. The Roper steam velocipede was a steam-powered velocipede built by the inventor Sylvester Roper in Roxbury, Boston, Massachusetts, sometime from 1867 to 1869. Same story, a standard steam engine attached, this time to a rear of an iron frame standard bicycle. But if the definition of a motorcycle requires an internal combustion engine, as asserted by the Oxford English Dictionary and others, then we have to wait a couple of decades to the Daimler and Maybach Reitwagen of 1885. Daimler created this machine to prove that his grandfather's clock engine could work in a vehicle. Please visit this podcast site to see fancy pictures of these early prototypes. For those into motorcycling, when someone tells you how dangerous driving a motorbike is, you can always say it was way more dangerous only a century ago, with the 19th century steam engine running very close to you, only 10 centimeters below your seat. Now sit comfortably and get ready for Professor Drew's interview on human factors. We are pretty sure you will like this one. Hello, today we are with Professor Frank Drews from the University of Utah to talk about a very demanding topic nowadays, human factors. Frank Drews is Director of the Center of Human Factors in Patient Safety and Director of Human Factors Program at the Psychology Department. Professor Drews is also President of the American Psychological Association's Engineering Psychology Division. Hello, Professor. Thank you very much for joining us. Can you introduce yourself to our audience?
Yeah, thank you actually for having me on your podcast series. I really think it's an important way of reaching out and to disseminate up-to-date research. So thank you for the invitation. My background is in cognitive psychology. I am trained as a cognitive psychologist and received my training at the Technical University of Berlin in Germany. I finished my PhD in 1999 and was actually happy enough to start a postdoc position at the University of Utah and worked in collaboration with one of my colleagues, David Strayer, initially a lot on driver safety, driver distraction. So we were interested in the cognitive elements of driver distraction. And in parallel, actually, I worked also as a human factors engineer in the context of healthcare, which is one of my current foci in terms of my research.
Mm-hmm. Professor, you are a reputed specialist on the human factors. And this is a very trendy topic nowadays in ITS, to be honest. Can you please define what is human factors and its relationship to intelligent transportation?
Human factors is involving research about the safety, efficiency of human operators interacting with technology and complex systems. The initial work in human factors actually was in aviation in the teens of the last century, early 20s in the last century. And of course, intelligent transportation or transportation in general is such a complex system. So the goal of human factors is really to create systems that in collaboration with engineers where we show that the goal of human factors is in collaboration with engineers to create systems that are safe, that are reliable and efficient, and that also actually allow for graceful degradation of the technology when actually the technology is not working, so that an operator can smoothly take over control.
Professor, we are living in a fast-changing world, also regarding transportation. Do you feel this excitement, the excitement of the big opportunity with all these new technologies that are quickly being applied everywhere, from industry to traffic management planning? Do you think this is the big time for human factors in transportation?
Absolutely. I really couldn't agree more. Yes, I think actually today in traffic management, in basically traffic control, in transportation, we are in a situation that is very similar to the situation we had in aviation at the time in the late 70s, early 80s with the introduction of the glass cockpit, where computers were replacing standard gauges. So today, cars, for example, have, at least up-end, high-end cars, have drive-by-wire systems, which means that we are digitizing the controls. This also allows us, in conjunction with the development and introduction of new sensors, to increase the wealth of information that is available. So now, this is an interesting challenge, of course, for people like me, because unlike the technology, our brains did not increase in our capacity to process information. So we now have a huge amount of information, and we are likely, if we're not very careful, to exceed the limits of human information processing. So human factors engineers developing new car interfaces are absolutely needed to solve this problem, this potentially threat of exceeding human information processing limits. And of course, intelligence to the traffic system being added increases even more the information processing demand for a driver. And so consequentially, we have to be very thoughtful about how to implement this. And I think this is why human factors today in transportation is such an important topic.
Mm-hmm. Such a big area, right?
It is, absolutely. I think most of my colleagues are very, very excited getting involved in this or actually having done research in this context for decades.
And perhaps the most important element may be its tight relationship with person safety. More than 1 million people in the world die every year in the roads. Can you explain to our listeners how can human factors improve road safety?
There are many, many systems that are currently under development or actually already have been launched to improve road safety. For example, we have systems that are monitoring driver impairment. So systems that actually monitor driver vigilance. They have been developed in the European Union, in the US, in Australia. And one of the ideas is really that we need to make sure that an operator is fit to operate the complex system as a car or a truck, for example. We can look at a vehicle, in-vehicle forward collision warning and avoidance systems. They all have these aspects involved. So these are systems that can make actually improve road safety, can make drivers safer. Of course, there are very important challenges associated with the introduction of these systems. One of the things we are very interested in is something that is often referred to as risk homeostasis. The idea is really that a driver or any operator of a system, but let's focus on drivers here, likes a certain level of risk when they are engaged in an activity. And so the moment we introduce new safety features, we of course reduce the risk, the subjective risk a person experiences, and as a consequence, the driver is likely to engage in more risky behavior, compensating for the risk reduction. So if we look, for example, at data, the Traffic Injury Research Foundation showed that some drivers admit that they would actually engage in unsafe driving practices like driving distracted or in speeding if they knew that their vehicle was fully equipped with modern safety features. In addition, human factors is of course interested in helping people to better understand how certain safety features work. My car, for example, has safety features included. It took me a long time to understand, what, for example, they mean, how they work, and I'm not quite sure that I really understand it. So it is really critical to understand how technology works if we really want to use it, if we really want to master it. Lack of familiarity with how safety features work may actually have really subtle but potentially negative influences on a driver's ability to benefit from these safety features. So a driver, for example, who's unfamiliar with how the safety features on his or her vehicle work, or even what in my case, certain dashboard symbols mean, might really not benefit from all the features we implement in the vehicle. A good example, again, comes out of aviation in the context of flight management systems. So these are systems that automate flight. So pilots often do not actually know in which mode this flight management system is operating. As a consequence, what is happening is the pilot is really always second-guessing what the system does. Ironically, the system was designed to reduce the cognitive demand when operating, when flying. And now, basically, what it does is it's actually increasing it. So this is what people refer to as one of the ironies of automation.
Mm-hmm. Professor, perhaps you've heard of a terrible accident in northern Spain where apparently for some reason a train driver did not brake when he should, and the train faced a turn at twice the maximum permitted speed, resulting in many fatalities, injured people. Supposedly, there should have been an alarm that the driver just ignored. Can human factors research cope with this? How can you work with the unpredictability of human beings? Or do we finally have to trust and close our eyes?
Well, I think actually this is an incredibly important topic. I think with regard to the specific accident, it is a little bit too early to actually say something. One of the things that could have happened is just, pure violations. So the driver actually was intending to violate something. So he had awareness. Another situation, and this is where your idea of an alarm comes in, was that he actually lacked situational awareness. He didn't know what was going on, and as a consequence, an alarm could have reminded him. So if we think about alarms, actually, and I think it's a really incredibly important topic these days. If we think about alarms, of course, we can think about domains where we have many, many times false alarms. So as I mentioned, some of my research is in healthcare, and we know that, for example, in the intensive care unit, 90% of all alarms are clinically irrelevant. So what it means is nurses are ignoring these alarms. Often this is referred to as cry-wolf phenomenon. Of course, the issue is really that what happens if an alarm is really clinically relevant? And then bad things may happen. So alarms are really in a way, a problematic technology, because what they really do is they inform us that something is going wrong. But if the system were better designed, the idea would be that the operator actually would have a higher level of situational awareness, and as a result would be able to predict that things are going wrong before the alarm is activated. Alarms are not very smart, and they are kind of threshold crossing devices. And I think if we can develop better systems, people would be better informed. And so an alarm is really one of the last defenses for breakdowns. Human factors research is really interested in all of this. Unpredictability of human behavior is, of course, an issue. I think you're totally right. The problem is really we have to understand better when can we predict behavior and when can we not. One of the things I'm very interested in is what I refer to, or what we refer to in our publications as adherence engineering. How actually can we make people more predictable by shaping the environment in which people are working? So in our case, we're interested in complex procedures. How can we make people violate less often standard practice? So in a way, you could also argue that it is kind of problematic to actually frame the issue, really, the way you do when you say, oh, it is the operator, it's the lack of predictability of human operators, because it pins really technology against human operators. And I think this might be an issue. This is traditional thinking. We have operators, we have technology. One fails, it must be that person's often fault. Now, I think actually, because it is thinking of the past, human factors engineers, often when we have these breakdowns in systems like this, we're not really involved in the development of the technology. And today, I think, my field, being involved early in the development process of systems, can actually help to smoothly integrate technology and human operators. And then we don't actually have to deal with this issue of unpredictability.
Uh-huh. How about enforcement? Usually we use a system punishing bad actions, but we are not using perhaps enough enforcement for training drivers, etc. What do you think about that? Do you think that can be useful for ITS-based systems?
Yes, I think actually there is opportunity for us to do things. I mean, obviously there are already places where actually reinforcing positive behavior, non-deviant behavior, if you want, is actually reinforced. Think about insurance and the insurance companies that are giving you some bonus for not having an accident. That is exactly the trajectory. So if you're a safe driver, you actually pay less insurance. So that's kind of, I think, appropriate. Now, if we think about it, we can of course argue that a vehicle that monitors safe and unsafe driving, safe driving following the speed limits, not, turning at a high speed in curves and things like that, that actually would be something where the driver who is following all of these kind of limits, should actually enjoy some privileges. Maybe, for example, providing drivers who are having a very strong safety record, who are not engaging in practices of distracted driving, like talking on cell phones while driving, text messaging while driving. Maybe those drivers should get privileges, for example, privileges like accessing the high occupancy traffic lanes without passengers, so that they can actually move faster than others. On the other hand, it might be also possible you are talking about punishment. Some limitations might actually help. So if you have someone who is constantly violating speed limits, maybe reducing their speed limit individually might be another way. And of course, the most obvious way is really insurance rates. I mean, this is really hitting the pocket, hitting the purse of the person. And as a consequence, it actually will affect behavior in a strong way.
Mm-hmm. So in the end, money keeps the world running, right?
Yeah, just that. I mean, money is a very strong incentive, clearly. But, I think what it really is we need to be creative. And I think it's a good direction, But the problem is really also you will have a lot of people who will say, I don't want a big brother watching over my shoulder. Mm-hmm. So there will be actually resistance, So we have to find out. And the insurance industry is, if they start monitoring the amount of miles you're driving, that's, where they start hitting a wall where people don't comply. So it's an interesting trade-off between maintaining individual liberties, but also, having people conform to standards that we decided as society are, minimum standards to assure safety.
Mm-hmm. Thank you, Professor. But very interesting indeed. Well, we now need to make a short break, but we will be back fast, so please stay tuned. Hello again. Are you enjoying this interview? It looks like human factors is becoming more and more important for ITS, isn't it? If you like this publication, we have to ask you for your help by following us in Twitter, Facebook and Google+, and retweeting or sharing our posts every time you can. That is very important to make this new publication widely known. We are also keen on listening your feedback. You can post your comments at our website or using our social networking accounts. And if you are not very much into social networking, do not worry. You can receive an email to your inbox every time a new episode is published. So don't hesitate, find the follow button at the lower right corner of our website, itsp.cicei.com, and enter your email address. It's easy. Anyway, thanks for listening to our show. Let's get back to human factors versus ITS. Okay, Today we are back with Professor Drews talking about human factors and its relationship to intelligent transportation systems. Professor, we know that there are research projects on the detection of fatigue, drugs-induced loss of attention. Furthermore, I think you once said that the loss of attention due to the use of smartphones is equivalent to drugs-induced loss. From the psychological perspective, do you think that that kind of developments will become pragmatic enough to be standard in future vehicles?
I think there is certainly a movement towards implementation of these types of safety systems, like, for example, monitoring for driver fatigue. However, we talked a little bit earlier about it. It's also important to create incentives that make clear to a driver what the benefit is of having such a system. Without understanding that, a driver can always ignore the fatigue alert, for example. You have per close as a measure of, identifying that a driver is likely to fall asleep. But, there are many, many drivers who would just continue driving, even if you have an alarm going on. They may actually disable the alarm. So overall, this is related to the question of what is desirable. So what is actually something that is really helping people as opposed to what is possible in terms of the technology that we can use. And sometimes it is really important to understand that things that are possible technologically may not actually necessarily be desirable. I'm not specifically saying this with regard to monitoring driver fatigue, but I think often what we do is we implement technology that actually then creates interesting complications. An example that I like about this is if you think about airplanes and automation. So in a way, today, airplanes have the ability, because aviation is less complex in some ways than driving, surface transportation, airplanes can actually have the technology and the capability of landing themselves just by a computer. Now, that is possible. Now, the question is really, is it desirable? And of course, you probably would say, I wouldn't want to fly in an aircraft that is highly automized, where there's no pilot on board. And why is this? Well, it is because we know we want a pilot to be a backup. We want a pilot to be in control. Now, the interesting thing in all of this is, of course, the moment you have a system like this that is automated, the pilot may step out of the control loop, which means the pilot actually loses knowledge, loses skill to operate the system. And in an emergency, the pilot may not even know what to do. And this is why we still have pilots land planes manually. So one of the ironies of automation is really that when we increase the level of automation in a system, what we really also do is we increase the requirements for training of the operator. So lots of training has to happen on the side. But in a way, because the operator has to be able to understand the system, what it's doing, it has to understand the automation, but also has to be able to step in an appropriate moment. And I think this makes it very, very challenging. And that's why sometimes, what is technically possible might not actually be what is desirable.
Uh-huh. And how about, talking again about future vehicles or transportation, how about decision making? Do you think that human factors will play a role there in the development of onboard systems for helping the decision making process?
I think human factors would be very, very important to make contributions in this field. Decision support is really, of course, in many domains, very, very intensely researched problem. Again, if we think about medicine and healthcare, for example, people have started working on decision support systems 30 years ago. But the interesting thing is, physicians did not adopt those systems. They are using them rarely because they don't trust the system, even if it has an error rate of 1%. Because they decide that an error rate of 1% is too high. If you kill 1 in 100 patients, that's not a good thing. And as a consequence, people have a hard time trusting these systems. Now, of course, if we could develop systems that are 100% correct, then people would trust the system because it would never fail. But then we wouldn't need people. So the problem is really, to trust a system, we need incredible high level of precision, which I think, from a theoretical perspective, is probably nothing we can accomplish because we are dealing with complex environments. It is never possible to predict 100% correct what is going to happen, what the scenarios are we are facing. So we call those scenarios often freak accidents, but freak accidents happen, and they will happen in the future. And this limits, how far we can push decision support systems. I'm not saying it is not important to do research, it is not important to try to implement them, but we need also to understand at what point do humans start trusting the system, and how do we allow them to actually be still critical of the suggestions the system is making. So again, it is about interfacing operators and computers or technology. A really exciting human factors topic.
Huh. So perhaps the problem is the interim phase, right?
Yes, I think so. But, I think research is moving so fast, so I think it is really exciting. And I think technologically we can find solutions. The challenge is really to engage operators. And, I think with ITS, we have a situation where we are really getting to the human, to the human operator very quickly. So it is possible to have a car like Google, the Google car, great, But I think what is really interesting is how do we transition control in such a way that we don't surprise the human operator? Because what I do when my Google car is driving is I will engage in other activities. I will prepare a lecture in the morning driving to work, or I will write a paper, or I will talk to someone on the phone. And does this allow me to seamlessly take over control? Probably not. So really interesting, challenging topics.
Mm-hmm. I have another example. For example, the Otis brothers invented the automatic elevator in 1924, but it was necessary to 3 decades to pass by until the people started getting into that boxes without any human operating them. So as a human mind researcher, you think we'll get at least a very gradual process, or do you think we will never be able to release that wheel and allow the car to drive by itself? What do you think?
No, I think we will be able to release the wheel, but I think it will take a lot of additional research. People were fantasizing about this in the 50s. I remember reading, when I was a child, books talking about nuclear power plants in cars and, flying cars. And, I think we have these fantasies, and they are good because they inspire us. They try to help us achieve more ambitious goals, accomplish more ambitious goals. But I think on the other hand, we also have to acknowledge there's a lot we don't know at this point. And so it requires more than just the kind of development of the sensors and the development of the intelligent system to actually have cars drive themselves safely. And again, it is about predictability, partly of the operator, but also partly of the environment. And your example earlier about the train accident, the train crash in Spain, is really an interesting one, because what we did in a way in that context is we take away degrees of freedom when we have a train, because the train, you can't change direction. You just have to follow the rail. And in cars, we have these degrees of freedom available. And so how to constrain this, how to deal with all of this is interesting. We still have train accidents despite the limited degrees of freedom. How will we deal with an increase in degrees of freedom in operating these systems and trying to reduce the number of accidents? I think this is really one of the interesting questions.
Mm-hmm. Thank you. Okay, just one final question about legislation. Professor, do you think that lawmakers and infrastructure planners are taking into account these elements you are talking about when making laws or new roads or signalings What do you think?
Excellent question. I really think it's important. So I think often what we see is, of course, that legislative kind of efforts actually create all kinds of obstacles. On the other hand, you would want our lawmakers to be informed by research. Now, having done quite a bit of work on distracted driving, I basically conducted research and published research that was of immediate relevance for lawmakers. So, showing, for example, that someone who's talking on a cell phone is as impaired as someone who is legally drunk, should have implications. Showing that cell phone use while driving, independent of hands-free or handheld technology, impairs a driver equally, should have an impact on legislation. Now, you can ask, how many countries are there that take this kind of finding, this set of findings, that it doesn't matter if it's hands-free or handheld, serious? How many countries are there worldwide that have banned cell phone use completely?
Don't know one. I don't know one.
I am not aware of a single one. I think there were efforts in Ireland, if I'm remembering right, and I think Ireland may have actually moved ahead, but most countries don't. And so what we are dealing with, and I think this is, again, social component, political component in all of this, we are dealing with many, many interest groups that have an influence on how laws are being made, So the cell phone industry has a significant influence on not banning cell phone use while driving, because about a third of all minutes are being generated while driving. So they would lose a lot of money if we would completely ban cell phones. Now, with the development of these new technologies in vehicles, intelligent transportation systems, what may happen also is that there's a significant monetary impact on this, which will have an impact on the development of new laws. And so I think we will see. I hope our legislators try to be more informed by research, but my personal experience is that the impact of research is there in some ways, but it is not as strong as I wish. And there are many other influences that actually drive the kind of creation of new laws.
Interesting. Okay, Professor, thank you so much for your deep, insightful comments. I think our listeners will really enjoy this episode, thanks to you. So thank you very much, Professor. I hope to meet you soon.
Thank you very much, and it was a pleasure. Thank you.
Goodbye, Professor.
That was all for now. Please send us your comments to tell us how you liked it. We are also expecting your wish list for future topics and personalities. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society website, designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain, soundtrack developed by Rubicon, language advisory by Manuel Arbelo. We'll be back soon bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.